Wow, it's Thanksgiving weekend, and I'm sure you guys are all studying hard, getting ready for Unit 4, Day 1. But in order to get done with you, get that going, in order to even know what I'm talking about, I gotta drink me a little bit of Brugger's coffee. Brugger's, I appreciate the thousands and thousands of nothing you've sent me, even though I've given you free airtime on like my YouTube channel. Hello. Holy mackerel. Holy mackerel. Okay. Let's get going. Warm up. Warm up. What are we doing? What are we doing? Okay, so this is going to be a warm up in class, remember? I'm going to ask you to graph this line. No, I'm not asking you to actually graph it. I'm asking you to just give me a quick little sketch of it. Quick little sketch. Ooh, right eye's not working. So, if you remember correctly, this is the y-intercept. So we'll put a little dot right there. And we know the slope is positive, so we go something like that. Something like that, right? Where the domain is negative infinity to positive infinity. Range is also negative infinity to positive infinity. Wow, uneventful. Over here, same y-intercept, but now my line is coming. I told you I need a new computer. Thank you, Brugger's, for helping me with my GoFundMe page and helping me with my Brugger's Bagel. By the way, if you hadn't hit the subscribe button, hit the subscribe button. By the way, if you're another teacher using my materials, that's cool. Love it. Great. You might want to hit the subscribe button. Tell your kids to subscribe to my YouTube channel. That way I get a little bit more, that you get a little bit more. And, if the ads come up that you like, click on them. If you don't like them, don't click on them. But if there's something that pops up and you want to click on it, click on it. It goes from negative infinity to positive infinity as well. And this range as likewise negative infinity to positive infinity. Those are some really sick infinities. I think if I had an Wacom Intuos tablet, not this thingy, I might be doing better. Maybe that's my next purchase. Anyway, how many roots does it have? Roots. Roots are the same as zeros, is the same as x-intercepts, is the same as solutions. Does f of x have? So it has 1 here. And in this case, it also has 1 here. So in this case, the answer is 1. In this case, the answer is 1. Wow, exciting stuff. Let's go down here. Now, we should know a little bit. Now, I just want a quick sketch of this, but I did ask for the range. So in order to figure out the range, that's going to be a little bit trickier. Not bad. Let's do it by hand. I mean, I could do it using my calculator. So x equals negative b over 2a, which is negative 2 over 2 times 2, which is negative 1/2. Oh, man, I was not nice to you. Okay, let's talk about, what I want to do is actually get a quick sketch. And I don't really want you to have to sweat too much about this one. So a quick sketch would be this. Here's the y-intercept. Because this is a 2, first of all, because it's positive, it's going up. And because it's a 2, it's going to be a little bit steeper. So it might look something like this. I'm not exactly sure. But I do have my calculator ready to graph. Domain's pretty easy. Oh, I'm just rebooting my computer and all my stuff, and it just updated, so I might get some funky stuff going on. Maybe that's why it's running so slow. It's doing some weird stuff in the background. Domain for parabolas, and you should have known this was a parabola because it had just one single x squared there. The domain for parabolas is always infinity to infinity, negative infinity to positive infinity. The range is, thank you. Go away. Go away. Thank you. The range is from whatever this low minimum, this is a minimum in this case, vertex is. Now, in order to actually figure out what that is, I might have to come over here to my graphing calculator. And in order for you to be able to see this and not my bald head, let's do this. I know you guys are like, I'd rather see your bald head, Mr. Krause. You need help. Lots and lots of help. It is a gorgeous head, though. Oh yeah, got up this morning, buffed it pretty quickly, got everything buffed properly. Much better, much better. I forgot what I'm doing. Let's see, we're going to graph mode, and we got to graph this thing. I think it was 2x squared plus 2x minus 1. Well, I should have done one thing. Before I even graph this, I'm going to go back to looking. I graphed it. But before I graphed it, I also should have known one thing. It wasn't going to have its vertex over here, because when I did the axis of symmetry, I got -1/2. I should have known the vertex was going to be over here somewhere, and it was actually going to go up like this. So these are some kind of things I want you to start to recognize, or at least to be able to sketch and visualize. I still need to know what this minimum y value is. I don't know what it is. It's down here somewhere. I can just go into menu, analyze the graph. Yes, I know it means analyze. And we're going to minimum, and we'll click here, and it looks like it's -1.5. So my range then would be -1.5 to infinity. Now over here, let's do a real quick axis of symmetry. Same y-intercept. X equals -b, which is -2 over 2 times -2. In this case, it is +1/2. So the axis of symmetry is along, let's say, this line right here. But because this is a negative, I know it's going to be a maximum, and it's going to be coming down like this. I'm just not really sure. So the only thing that changed was my leading coefficient is now a negative. So let me hit the tab button. Let me hit the up arrow button. I'm going to go over here and put in a negative and hit enter. Wait a second now. It doesn't have any real roots. Ooh, that's weird. So I didn't know that, but I knew it was an upside down parabola. I knew it went through here. I knew it was going to have its vertex at 1/2, but I didn't know that it was going to be there. So I need to figure out what that is. So in this case, we're going to go to menu, analyze graph maximum, left, right, boom, and it's at -0.5. So my domain, as always, -infinity to +infinity. But my range in this case is from -infinity all the way up to -1/2. Including that. Now, how many roots does this one have? This one has 2, and this one has 0. The only other thing you can have with roots with a parabolic curve or quadratic is 1 root. Remember, if it hits the root once, it's a perfect square trinomial, it'll hit just once. So you can either have 1, 2, 1, or 0, and these, of course, then would be imaginary roots, correct? All right, let's keep moving. Let's keep grooving. What's that you say? Mr. Krause, you haven't had a drink of your Brugger's coffee, your delicious Brugger's coffee in a while, and you might need some because you're looking like energy's a little bit low and your pen's not working, so maybe you need a break anyway. When my pen doesn't work, when I'm working with my old laptop, I turn to Brugger's coffee. It's kind of like caffeine on I don't know. It's just good stuff. Of course, my pen's not working. There we go. So what I want you to start to look at is we're going to start to look at this thing called end behavior and roots and shape. So what I want you to think about is, where's Mr. Krause's pen again? There it is. We have a cube root function here, and I have a cube root function here. Now, I'm not so much concerned about all this little craziness in the middle here. Not worried about this craziness in the middle. What I'm concerned about, or what I'm interested in, is this end behavior. This is going up. This is going down. This is going up here, and this is going down. What do you notice? What do you notice? All right, let's talk about this one. Domain, -infinity, +infinity. Range, -infinity, +infinity. Is it a function? In this case, yes, it is a function. Sometimes cubics are functions, sometimes they are not. Is it a one-to-one function? It passes both the vertical and the horizontal line test. Actually, sometimes they're one-to-one, sometimes they're not. In this case, yes, it is a yes. I'm trying to write yes. If my pen was working, I'd be writing yes right there, not just weird little click marks. That's a yes. That's better than some of my boys' handwriting. Oh, you know it. Oh, don't make me start calling some of you out. And how many real roots does it have? In this case, it has 1 real root. 1 real root. That means it probably has 2 imaginary roots. Ooh, we'll talk about that later. Domain here, -infinity to +infinity. the range here is also negative infinity to positive infinity. Now, I don't really care what it's doing in this little swoop-de-swoop, loop-de-doop, and doop-de-doop stuff right here. I don't care about this. Man, I'm getting seasick already. I don't care about that right now. What I care about for range is, what is it going at the ends? Is it going left forever and ever, right forever and ever? Is it going up forever and ever and ever, down forever and ever and ever? All right. Is this a function? Yes, it passes the horizontal, or excuse me, passes the vertical line test. But in this case, obviously, it fails the vertical line test. So in this case, it is not a one-to-one function. How many real roots does this one have? Well, if I look through, I got 1, 2, and 3. So 3 real roots. Now, in this case, you can have 0, 1, 2, or 3. Wait. I apologize. You cannot have 0 and you cannot have 2. You can either have 1 or 3 real roots, not 2. We will have a discussion about this. So in this particular case, the degree was a 3, and it went up this way forever and down this way forever. In this case, it was a negative. It was an odd, and it went forever and ever up and down. Let's go back up here real quick. Let's go back up here and look at this one. This one, what's the exponent right here? What is the exponent? I'm hoping you're all saying 1. Well, yeah, 1, it's going up forever and ever in that direction, down forever and ever in that direction, up forever and ever in that direction, and down forever. Does anybody notice anything? Did you see anything? On the one where it is a positive 2, it goes up, up, up to the right, down to the left. One where it was a negative 2, it went up to the left and down to the right. Now let's go back down here and take a look at this odd function. This is another odd function, but in this case the leading coefficient is positive. It's going up in this direction, down in this direction. Notice if I drew that line in, that would have a positive slope. This one here, going up in this direction and down in this direction. And again, if I completed that line, that would have a negative slope. Negative. All right. Thinking about that. Keep using your brain. Okay, here we go. We now have a 4th degree polynomial. And in this case, it's going up in this direction and up in this direction. And this is another 4th degree polynomial. Not much has changed. In fact, the only thing that looks like it's changed is that it went from a positive to a negative. But notice it's now going down in both directions. So let's talk about domain. Domain is negative infinity to positive infinity. But the range is slightly different. And let's just estimate the range here. Let's say that's negative 2.5. So it goes from negative 2.5 all the way up to infinity because it's going forever and ever up. In this case, the maximum value here looks like it might be a little bit less than 1, 2, 3, 4. So domain is negative infinity because forever and ever left, forever and ever right. But it starts at negative infinity and comes up to, let's just say that's 3.75. Not exact, but I don't want to have to bust out the calculator. I just want you to get the idea of what's going on here. Is this a function? Yes. And so is this. Are these one-to-one functions? No and no. How many real roots? Well, in this case, it looks like it has 2 real roots. And in this case, it has 1, 2, 3, 4 real roots. Wow. 4 roots, 4 solutions. Now, one of the things I want you to start to look at now is, let's go back and look at this parabola. It was a 2 here, and it went a positive 2 and a 2nd degree polynomial, and it went up. This was a 2nd degree polynomial and a negative 2, and it went down. Go down here. This is an even 4, and it's positive. It's going up. This is an even 4, and it's going down. So it looks like when it's an odd function, it goes off in either direction. It's like an odd person. They're always constantly going all over the place in lots of directions. About a person in an even direction, you're going to go up or you're going to go down. All right, so that's what we're talking about. So notice we have an odd function. It is an odd function with a positive leading coefficient. So as I go from left to right, it should have like a positive slope. It's a way to remember. It's not exactly what's going on, but way to remember is that it's going to go up right and down left. Well, odd functions, the range and domain are going to be negative infinity to positive infinity. They go up forever and ever one way and up negative and ever in the other direction. Is this a function? Yeah, it passes. Is it a one-to-one function? No. And how many real roots? Looks like it has about 3 right there, right? Domain here, negative infinity to positive infinity. Range, negative infinity to positive infinity. Is it a function? Yes. Is it a one-to-one function? Oh, no. This is also not a one-to-one function. And this one had 3 real roots. But notice it's got a negative in the front. Notice it's got a negative in the front, so it's going up left and down right, just like a negative line would go up left and down right. So let's talk about end behavior. Positive odd. What would that look like? Positive odd. Well, the one thing I want you to remember about odd, so this is going to be the odd functions up here, is it's going to either go up in one or down in the other. So let's say our function was something like f of x equals 2x cubed. Now, when I'm talking about odd, I'm talking about the exponent. When I'm talking about positive, I'm talking about the leading coefficient. So it's a positive leading coefficient and an odd degree. Well, if it's positive, just like with a linear function, if you had a linear function that was, if you had a linear function that had a positive leading coefficient, it would go up in this direction. Well, that means that it's going to go, if it's a cubic, it's just going to look a little wiggly, but it's still going to do that same thing. So as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. Does that make sense? A little arrow. What they're saying is as x gets larger, y gets larger. As x gets smaller, y gets smaller. Negative odd correlation. Negative leading coefficient, odd degree. So that would be something similar, but negative 2x cubed. Or f of x is equal to negative 4. It could be a 5. It could be a 6. X to the 5th. It doesn't really matter. What we want to know is, if I had to sketch this, it would be coming down like this. So what I want you to remember is as x gets large or goes towards positive infinity, y is going to get small or go towards negative infinity. As x grows to or goes to the negative infinity, y goes to the positive infinity. Gets bigger. Positive even. Now what I want you to remember about even is it's either going to go both up or both down. So if it's positive, so that's what we want to know about even. It's either going to be both up or both down. So if it's positive, something like 3x squared, or y, or we could do y equals 6x to the 4th. Whatever, it doesn't matter. If it's positive, the positive means it's going up. If it's even, that means it's going the same direction. So in this case, as x goes to positive infinity, y goes to positive infinity. And as x goes to negative infinity, be careful here, y is going to positive infinity, because it doesn't matter if I go to the left, it's going to go up, and if I go to the right, it's going to go up. Now, when it's a negative leading coefficient and even, that's the case where it's going to come down like this. So if I had to sketch this, it's going to be a picture that's coming down, but it's going in the same direction, arrows. So as x goes to positive infinity, y goes down, or goes to negative infinity. As x goes to negative infinity, y goes to negative infinity. So odd functions go off in either direction, positive or negative, and even functions either go down or go up. It's called the end behavior. That's what we're talking about. What's going on at the ends. And after I describe end behavior, I have to take some Brugger's coffee. Take some. It sounds like I'm taking medicine. I'm really not. I'm just drinking. And yes, it's just coffee. Thank you very much. This craziness, personally brought on by Carlton Krause. Oh yeah, that would be my dad. He's a little nuts. I know. Yeah. Have you seen him? He's a little crazy. Where do you think I got my craziness? Now, so what you need to recognize is odd going off in either direction. Now, if you want to bring it back to lines, because you know a lot about lines. So if you had a negative slope line, wouldn't you say it's going down like this? Right? So in this case, because it's a negative odd correlation, but it's a cubic, it's going to go and have some wiggles in it somehow. A little bit of wiggly stuff in it. So as x goes to the left, or as x gets to the negative infinity, so as x is going this direction, where's y going? Oh, y is going to positive infinity. As x goes to the right or towards positive infinity, what's y doing? It's going towards negative infinity. The maximum number of roots for a cubic would be 3. The minimum would be 1. Now, why would it be 1? Well, think about it. Is there any way that a cubic that's going to go up in one direction and down in the other not cross the x-axis? So here we go. We got an odd function with a positive leading coefficient. So in this case, think about a line that has a positive slope. Lines are first degree or odd, but it's not going to look like that. It's going to look funky, especially when it's a fifth degree. So in this case, it's going to go kind of like something. I don't know. It won't look like that, but I like drawing funky stuff. So as x grows towards negative infinity, then y will go towards negative infinity. Oops, didn't need those parentheses. And as x goes towards positive infinity, y goes towards positive infinity. But again, the maximum number of roots is 3 and the minimum is 1. So we've got a even, which tells us we're either going both up or both down. In this case, because it's negative, they're both coming down. So draw a quick sketch. Doesn't look anything like that. I draw a parabola. You don't want to draw that? You don't like that sketch? You draw, and you say, oh, it's a 6 degree. Oh, it's got to have some wiggles. Whatever. I don't care. They're both coming down. So as x goes towards negative infinity, y goes towards negative infinity. As x goes towards positive infinity, I don't know why I keep putting these lines here. Y goes towards negative infinity. It doesn't matter which way x is going, this way or this way, it's coming down. Oh, how maximum number of roots? 6 times, the maximum number of times. Now the minimum could be 0. Now you're thinking, oh, the minimum has to be 2, because look, at minimum it's going to hit it twice. But don't forget, I could have a sketch that looks like this. It's coming down, and it could have a few wiggles in there, and it could just go down like that. So it could have 0. It could have 0 real roots and lots of imaginary roots. Imaginary roots. When I talk about imaginary roots, I take in some simple goodness. Simple goodness. Okay. Even leading coefficient. No. Positive leading coefficient. Even exponent. That means it's coming up. It could look like this, where it doesn't hit it at all. It could look like this, where it hits it lots and lots of times, it doesn't matter. It's going up. So as x goes to the left or goes towards negative infinity, y is going up. As x goes towards positive infinity, y is going up. Maximum number of roots, 8. Minimum number of roots, goose egg. Describe the degree and leading coefficient of the polynomial whose graph is this. So let's think about this. Opposite directions, up and down. That means it's an odd function. Now, I don't know if it's a third, a fifth. I know it's not a first, because a first would be a line. I know it's not a first. I don't know why Cortana came up. That was weird. And think about its slope. If you drew a linear function, that would have a negative slope, right? So I know that my leading coefficient is negative. I'll say less than 0. So it's an odd function that's less than 0. Now, in this case, I'm going up to the right and down to the left, which again means it's an odd function. That's probably where my bald head is. It's an odd function. And if you think about if you had a line going in this direction, up to the right, down to the left, that would be a leading coefficient that was greater than 0 or positive. If you want to write positive, because that makes you feel better, write positive. But you guys got to get in the habit is greater than 0 does mean el positivo. That was my good Spanish for the day. So now what I want to do is sketch. Now, anytime a teacher tells you to sketch, this means it does not have to be too accurate. It has to have some accuracy, but it doesn't have to be too accurate. So, a polynomial with a leading coefficient that's negative. So, LC is negative, and the highest degree is 4. So, 4, because it's even, they're going to go up or they're going to go down. Okay, and because the leading coefficient is negative, just like with negative parabolas or negative leading coefficients on parabolas, it's going to be coming down. So if I had to draw a quick sketch of this, I would draw something that looked like this, maybe. Again, since it's a 4th degree polynomial, the most number of solutions I can have is 4. Okay, and it's coming down. Next problem. A polynomial with a leading coefficient, again, that's positive, but its highest degree is, and I don't care about its 5, I care about its odd. Remember, I don't care the 5. Again, up here, I didn't care about the 4. What I cared about was that it was even. I just like saying even. So, think about a line when you're going to draw these. A line, if it had a leading coefficient that was positive, would draw like that. Now, because this is a 5, you cannot draw a line. You can't draw a line. So the only thing that you can give me is it's going to go up from left to right, and it's going to have a little squiggle in it. Does it look like this? Probably not. But it's got to go from up to the right and down to the left because it's odd and because it's positive leading coefficient. All right, kids, we're almost done. Sketch an even degree polynomial function that has no x-intercepts. Now, because it's an even, I'm going to draw 2 pictures here. Okay, because it's even, that means they're both going up or they're both coming down. So I could draw, let me draw some axes in here, get some good solid axes in there. And I'll go over here, we'll go black and red. I could draw a picture that looks like this. This would be a even function with a leading coefficient that is negative or less than 0. Or I could draw this picture. Again, if you just draw a parabola, it's fine too. But again, this is an even with a leading coefficient. In this case, that's positive. But notice it never hits the x-axis. It never hits the x-axis. Therefore, no real solutions. Can you sketch a degree of odd function with no x-intercepts? And we've already talked about this because odd functions, whether it be odd positive, so this would be odd, leading coefficient that's positive, or an odd negative, it must hit it once. So the answer to the question is no siree, Bob Taylorinsky. And kids, day one is rocked out. Hit the like button, hit the subscribe button. Leave a quick comment like, yo, Kraus, your hair looks amazing. Oh, yeah. Buffed it up just for you guys. Kraus, I'm tired of the coffee commercials. Pick something else. Oh, yeah? What am I supposed to do? Huh? You tell me. Hit the like button, hit the subscribe button. Hit the donate button, and you'd be my hero. I need a new computer. My wife asked me what I want for Christmas. I said computer. I think I'm getting a divorce. She thinks I'm a nerd. She's right. It's all. Goodbye, kids. It's been fun. It's been real, but it has been real fun. Bye.